Hello and welcome to this GitLab Admin Fundamentals episode. My name is Sander Brine, Customer Success Manager for GitLab. And today I would like to talk to you a little bit through managing your instance. When you are a GitLab admin, you want to do certain tasks in your GitLab admin area. And of course, managing your instance is a big part of that. What does it mean, managing your instance? Yeah, there's a lot to manage with GitLab. As an admin, GitLab admin, you have access to several dashboards to manage, for example, your runner fleet or your background jobs, and also view your system status. Today I also want to talk you a little bit through the GitLab architecture so that you have also an idea on, okay, what does a typical GitLab architecture look like and which components make GitLab. So let's go through that. Now, first then these key components. GitLab consists of these important components, which is the Rails server, the application server that contains the most important application logic. We use Puma as the Rails application server. Then we have our database, PostgreSQL. You can either use an external PostgreSQL or use the one that's bundled within the Omnibus installation. Another important part is Sidekick. Sidekick is a background processing tool, so it's running all kinds of background tasks. And also all your build jobs are queued into Sidekick and to be executed in a runner later on. To improve performance, we added Redis as sort of a cache server in memory so that we can do a lot of transactions and options in memory, which speeds up the instance. As a sort of a front-end tool, we use Nginx as a reverse proxy. With larger installations, you can also use other additional proxy servers, but bundled with GitLab is Nginx. Then we have GitLab Shell that's handling all the Git commands for GitLab. It's sort of an intermediate between Rails and Gitly. Gitly is the backend engine for Git, so all Git-related operations go through Gitly, and Gitly handles then the storage to the Git repositories. And then we have the GitLab workhorse that handles large HTTP requests and also the Git clone over HTTP. Now, these are sort of the core components. There is more. So if you look at a typical GitLab architecture, you also see, for example, Consul or Prometheus and Grafana later on those. But also for premium instances, people might use Elasticsearch for advanced search or OpenSearch even. Which is also an important component. And on file storage, you can use several storage solutions there, where, for example, the database and Gitly require very dedicated and fast object storage, but for other parts of the systems, you may also use NFS. But NFS is not supported for Gitly or the database. That's very important to understand, and I'm not even sure for Redis or Elasticsearch. So all these components that require fast disk access, they rely on fast object storage. Components that don't require this fast disk access may also use NFS. Cool. Now let's move on. With GitLab, with all these components, GitLab is highly scalable, so you can scale it in many ways. And one of those is geographic replication. This is often used in several use cases. For example, when you have distributed teams across the world, you might use geographic replication to reduce latency. So people, for example, in this example, in the Netherlands, may have a much better performance in pulling repositories from the mirror side rather than pulling it from the primary, which is in San Francisco. But all write operations still go to the primary to prevent any late updates. So you don't want a write operation on a mirror that needs to then be synced with the primary, which takes more time. So it's a performance improvement, but also, for example, if you want disaster recovery failover, then you may have a separate instance in another availability zone that acts then as a secondary, and this secondary can be promoted to primary whenever the primary fails or is unavailable or whatever. Also, what we also see Geo used is when you want to migrate, for example, large instances from one installation to a new infrastructure or architecture, then you can use Geo to sync all the data from the primary to the secondary. And once both of these are in sync, then you can promote the secondary to a primary, and then at the end shut off the old secondary, so to say, and then your new primary instance is then your new installation. So that's a few different ways of using Geo. The installation is a bit more complex, but very useful in large installations. Yeah, I discussed this disaster recovery or failover situation where you want to have a secondary to be able to act as a primary. Now you want to also test that. If you want to do that, then another option is to put GitLab in silent mode. You can enable silent mode in the GitLab UI, which silences most outbound communication like emails, system hooks, webhooks, HTTP traffic, it's outbound, etc. Some communication is not silenced. For example, the dependency proxy might still pull images from the remote source when it's not cached. And also file server hooks are not silenced. Advanced search is still making updates, but also the container registry webhooks run because they are external. That's about the Geo installation. We also have this component which is called GitLab runners. GitLab runners are a very important part of GitLab. The GitLab runner is responsible for running all your jobs in your CI/CD pipeline. A GitLab runner is a very small, lightweight agent that's running on a separate VM, or maybe it can even run on your laptop if you want to. Your GitLab instance does not need to know about the system where your GitLab agent is running on, your runner agent is running on. The runner will access GitLab and will register itself at GitLab with an authentication token and sets up a bidirectional communication line so that GitLab is able to reach the runner when it has registered itself and then send jobs to it. Runners can run everywhere. I've even seen runners running on Raspberry Pis in a cluster. So a lot of Raspberry Pis that were connected to very specific hardware devices, and then were able to run tests on these hardware devices. So these runners are very flexible and very easy to run everywhere. Now, how does this runner architecture work? How does it interact with GitLab? Now, the GitLab runs pipeline. So a pipeline is triggered, for example, when something is pushed or a merge request is merged. And then GitLab determines which jobs make that pipeline. That's checked on runtime because pipeline configuration can be very flexible, and not with every event the same jobs will run. So at runtime, it will check which jobs make up this pipeline at that time, and GitLab will schedule these jobs in a Sidekick queue. Now, whenever a runner is ready, then Sidekick will push that job to the runner so that the runner can run it. It's executing it either in Docker or in Kubernetes or in a shell or whatever. There's different executors that can be used in the runner that will actually run the job. But you can also sort of determine a little bit which job should run on which runner, and that's done through tags. So you can set tags on both the job and on the runner, and when both tags match, then the job is run on that specific runner. multiple runners can have the same tag, of course, which means that this job can run on any of these runners with those tags. On the other hand, both jobs and runners can have more than one tag, and then the job is run on the runner that matches these tags. Another way to sort of make selective on which runner the job runs is through different types of runners. You have a runner that is running on instance level, which is a shared runner. You can also have runners on group level or on project level. A project will be able to access all the runners in his hierarchy, so in any of these parent groups and the instance level runners, the shared runners. But you can also define on your project if the project is using the instance runners or it's only using the project runners. And with that, if you disable the shared runners on project level, all jobs in that project will run on only the group runners. Another way is that you can link a runner to a project, so you can make that runner specific to that project through a sort of a link. That's not a project runner, but you can sort of dedicate a runner to a specific project, and then you know also that these jobs also run on that runner. Now, running jobs on runners is something that people notice, and also the most problems that you hear from users, from end users, is jobs are not running, or job running is slow, or pipelines are slow, things like that. If you have these questions, you have momentarily a few options. You can view our runner dashboard, and the runner dashboard gives you an overview of all different runner types. So it's giving you all the runners in the instance, not only instance runners, but also project runners and group runners. And you can see how many are online or offline. Stale runners are all these runners that have been online but are not responsive anymore. So the communication line is broken, either because the runner stopped or was the process was stopped but not deregistered. Stale runners, you can remove them here if you want to. You can also pause a runner if it has problems, so that other runners are picking up those jobs. And you can edit the runner, so that you can set some tags to a runner or link it to a single project, as I mentioned. You can edit the description and configure some options. For example, you can secure a runner or things like that. Cool. So that's on runners. But of course, jobs run on runners, so you also have an overview of all the jobs in your instance, and you can see the job status, which project it's linked to, but also on which runner it's running, and the duration, how long it has been running on that runner. You can immediately link to the pipeline that is part of the job, of which the job is part of, and see in which stage it's running. This helps you in determining if indeed job performance is decreasing, and if there's any problems with a certain runner or a certain project. And for example, when a person is coming to you with perceived performance issues with runners, you can ask on which project or on which job or which pipeline, and then you can use this dashboard to drill down and then see maybe which runner is giving the problems, because you have the link to the runner in this overview. Now, we also working on a new runner fleet dashboard, which is still in beta, and it's an ultimate feature, I must say. This runner fleet dashboard gives you a little bit more information on the runner. It also it's adding metrics if you have ClickHouse installed. So these metrics only work with ClickHouse. ClickHouse is a separate component, sort of a data lake that you have to install and then connect to GitLab, so it can collect data from your runner fleet. And when that's installed, then you can see these histograms, which are very interesting because runner performance is usually something that happens or decreases over time. So you have a sort of a base performance, which is perceived as okay, and then it decreases, which it's at some point becoming not okay. So therefore, these histograms are indeed very important. But also, you can see here sort of which were the latest errors you see, etc. So you have more information in one dashboard on your runner fleet. It's available as a beta feature behind certain feature flags, so you can enable it. Some of these widgets work also without ClickHouse. Check the documentation on what's working and what's not. Now, we also have a little bit system monitoring in the instance. So in the instance, you can see the system info page where you can see memory usage, disk usage, when GitLab has started late last time. It's very basic. We do recommend definitely to look into more advanced monitoring. We have Prometheus always bundled with GitLab. So there's a lot of data coming out of GitLab through Prometheus. You can then install your own Grafana and build a Grafana dashboard based on the Prometheus data. Now we have a lot of Grafana dashboards as examples that you can reuse, and then you can also integrate Grafana into the GitLab UI so that you can access it from GitLab immediately. Now, then GitLab maintenance, of course, every now and then you have to upgrade your instance. We have regular security updates and monthly bigger releases. Before you want to upgrade, you want to announce your upgrade plans. So you can place an announcement banner system-wide, or you can notify specific groups through a broadcast message. Once you've done that and it's upgrade time that you want, then you want to maybe set your instance in maintenance mode. If you completely shut down your instance, then maintenance mode is not per se necessary. But if you have like a failover situation, then it might be wise to put GitLab in maintenance mode, which puts GitLab to a read-only mode, mostly read-only. So all Git operations that include write operations will fail. But for example, the admin console is still accessible and other things are also accessible. But it makes your system easier to maintain and easier to stop processes and so on. Jobs that are running will still run and continue to run, although job statuses are not updated and no new jobs are scheduled. Also, deployments might not run, and you might also want to prevent automatic deployments running. So there's a lot of things, so please check out the documentation on maintenance mode before you are going to do this, and inform your team again about it. Then upgrade your instance. Now, that's something the people managing your infrastructure have to do. And once the upgrade is done, you have to check background migrations. Background migrations is those are sort of background jobs running through Sidekick after your upgrade that will finish any tasks that need to be done after your upgrade. These can run for hours or maybe even days to complete, depending on the performance of Sidekick, depending on the configuration of Sidekick as well. You can work with support using upgrade assistance to see if you need to reconfigure Sidekick temporarily to allow for more Sidekick workers to run these background tasks. Now, maintenance mode doesn't have to be enabled the entire time during background migrations, although having GitLab in maintenance mode might speed up these, but at some point you need to disable maintenance mode again so that people can start working again. Now, these background migrations, you also have an overview of these in the GitLab UI, so you can see in GitLab which background migrations are running, are still queued, or maybe have failed. Make sure that all of them are finished before you move to the next migration. So you cannot upgrade to another version if background migration tasks aren't finished. And if any of these have failed, please contact support and they will work with you to fix those problems. I already mentioned Sidekick. Sidekick is a very important tool in GitLab operations. A lot of background tasks run through Sidekick based on queues or other ways. And within GitLab, you can access the Sidekick dashboard to view the status of Sidekick. So you can see all the queues and all the scheduled tasks, etc. You can even delete or pause things here. For example, if you look at the queue pipeline processing build queue, then that's the queue where all the jobs from your pipeline will end in and will be processed from. And you can see size here, latencies, all kinds of information. If you experience problems running GitLab, especially running jobs, but also scheduled tasks, scheduled pipelines that are not running, things like that, you can have a look at Sidekick because most likely something is wrong with this. Then a final thing we have is a health check. We have 3 sort of stages in the health check that GitLab will check. First is simply healthy in terms of is the application server running, which is running through, which is checking the Rails controllers. It's a very simple, very basic check very early on in the process. So once GitLab is starting up, it will become healthy when the processes have started. That doesn't mean it's ready to accept traffic. That's the next stage, so to say. So you can configure it to check if you can really connect to GitLab. And with the all parameter, you can also probe for all the other components like the database, Redis, and Gitly to check if they are ready and to accept connections, to accept traffic. And then you have the liveness probe, and that really checks if the application is running and if there's not a deadlock, so if they're really responsive, so to say. So that's the final stage in an operating and running instance. Check if GitLab is still responding or not. If GitLab can be healthy and ready and still not responding because processes are deadlocked. So all 3 of these have to be healthy in order to have a fully operating instance. Cool. Now, having said that, let me show you quickly a little bit of what we have. And if I go to the admin area, you have here monitoring, where you have the system info, background migrations, background jobs. This is the Sidekick console. You also on CSD you have the runners. You can also edit the runner and configure it. For example, pause or protect it or lock to the current project. And in settings, you can set up the maintenance mode and a silent mode over here. So you can enable maintenance mode, set a banner message during maintenance mode, or you can put it in silent mode. If for example, in these failover situations. Now, very quick showing you what the admin area is doing. And with that, I want to thank you for listening and see you next time.